In this video we're going to look at molarity calculations when you are following a recipe for a solution or buffer in the lab. Now let's say you need to make up the following solution. As you can see, it's got 6 different components in it, and each one of these has to be weighed out and made up correctly for the solution to be correct. The question is asking some key points. The first thing it is asking for is the volume of the solution you need to make up, which in this case is 0.1 litres. The next thing you need to look at is the concentration of that particular component of the buffer or solution. In this case it's 155 millimolar. You also need to make a note of the molecular weight, which is 136.09 grams per mole. And finally, make a note of what the answer needs to be in. In this case, it's grams to 2 decimal places. Now, to answer this type of question, there are 2 approaches that you can take. You can take a walk-through approach where you reason to the answer, or you can use an approach where you use an equation or 2. So effectively what we're dealing with here is a 0.1 litre solution, and in that solution the concentration of potassium phosphate is 155 millimolar. Now 155 millimolar can also be expressed in terms of molar, and 155 millimolar is 0.155 molar. That's because there are 1000 millimolar in 1 molar. Now, if we had a litre of this solution, then that litre would contain 0.155 moles, because all molarity is moles per litre. However, we're not dealing with a litre in this case. We have got 0.1 of a litre. So therefore, to work out the number of moles that are present, we take the molarity 0.155 and multiply it by the volume 0.1, and this gives us the number of moles, which is 0.0155 moles. Now the next question is, how many grams of potassium phosphate is equal to 0.0155 moles? To work this out, we take the 0.0155 and multiply it by the molecular weight of the potassium phosphate, which is 136.09 grams per mole. And this gives us an answer of 2.109395 grams. So this 2.109395 grams is the same as 0.0155 moles. Therefore, we would have to weigh this number of grams out to get the amount of potassium phosphate we require. Now don't forget, the question asked for the answer to 2 decimal places, so the 2.109395 grams needs to be rounded to 2 decimal places, and this would give you 2.11 grams. Now the other approach to working this out is to use a series of equations. We know that the volume is 0.1 litres. Molarity is 155 millimolar, which is 0.155 molar, and our molecular weight is 136.09 grams per mole. Now the molarity of a solution is equal to the number of moles divided by the volume in litres. Our molarity is 0.155, and that is equal to moles divided by the volume, which is 0.1. If we rearrange this equation, we get moles, which is what we're trying to find. So moles is equal to 0.155 times 0.1, and this comes out to 0.0155 moles. Now the number of moles is equal to the number of grams divided by the molecular weight. Now we know that the number of moles is 0.0155, and this has to be equal to the number of grams, the thing we wish to find, divided by the molecular weight, which is 136.09. If we rearrange this equation to give us the grams, we come up with grams is equal to 0.0155 multiplied by 136.09, which gives us an answer for the number of grams we require of 2.109395 0.09395 grams, which when we round to 2 decimal places gives us 2.11 grams. And that's it. That's how we work out the number of grams of potassium phosphate that we require to make up 0.1 litre solution which contains 155 millimolar potassium phosphate.